On a clear day, satellites give us a wonderful synoptic view of the ocean, but we can only guess what lies beneath the surface. One way we can sample beneath the surface is with an oceanographic mooring, and while moorings provide detailed information beneath the waves, it is locked to just one spot. Or we may use a ship to steam over the area of interest, but a vessel can cost many tens of thousands of dollars per day. A suitable alternative is the use of so-called Argo Floats and ocean gliders, which measure the currents, temperature and salinity beneath the surface. Hi, my name is Ian Suthers and I'm a marine scientist at the Sydney Institute of Marine Science. I use data collected by Argo Floats and ocean gliders to study planktonic organisms, creatures that form the basis of the food web in the ocean. Every day, weather forecasters use temperature and salinity data from over 3,000 Argo Floats deployed throughout our oceans. The Australian contribution of 300 floats is led by the CSIRO in Hobart. Argo Floats are programmed to remain in the deep ocean at 1,000 or 2,000 meters deep for 9 days, and then rise to the surface on the 10th day, recording temperature and salinity at every meter. They rise and sink by delicately changing their buoyancy, using a piston to create a vacuum and inflate an external bladder with oil. Once at the surface, the piston then begins to draw the fluid back inside for the descent. Ocean gliders use the Argo principle of changing their density, but are carefully balanced horizontally and look rather like a torpedo, with a small pair of fiberglass wings just 30 centimeters long, and they rise and sink. Ocean gliders travel slowly at around 25 kilometers per day, or the old-fashioned term of around half a knot. There are two types of ocean glider that IMOS uses around Australia: Slocum gliders and sea gliders. The IMOS organisation that deploys and maintains this remarkable fleet is known as ANFOG, the Australian National Facility for Ocean Gliders, and is based at the University of Western Australia. Each of the 9 Slocum gliders costs around $150,000. It is 1.5 meters long and weighs around 50 kilograms, and is powered by 250 alkaline sea cells, which last 3 to 4 weeks. Slocum gliders are usually deployed near the coast, as they dive to only 200 meters deep and back to the surface every 10 to 15 minutes. Sea gliders, on the other hand, are slightly more expensive, longer and fatter, and comparatively sluggish, sinking at roughly 3 meters per minute. However, they are capable of gliding to 1,000 meters deep every 5 hours, and by doing fewer dives, their batteries last for 3 to 5 months. They are used to determine the internal structure of eddies and working deep in the Southern Ocean. Navigating a glider is always a challenge. Clearly at half a knot, we cannot take on the East Australian current, which is flowing at 3 knots. We have to fly the glider across the currents, just the same way as a surfer has to escape a rip by paddling across the flow. So navigation critically depends on proper interpretation of the currents. As the battery begins to fade, the challenge is to bring the glider close to the coast so we can retrieve it. We then have to make a mad dash across the shelf as it bobs at the surface, broadcasting its GPS position. Even then, it is hard to spot the glider in the trough of a wave. At the end of its mission and safely on board, the effects of its stay at sea may be seen. Biofouling has begun on the nose, on the wings, and around the CTD sensor. And sometimes a circular bite mark is evident on the hull from a determined shark. Gliders really are the ocean observing tool of the future, and could even replace moorings in the years to come. Just imagine replacing a mooring with all its shackles and weight with an elegant glider that profiles the water column every hour, broadcasts its data, determines its drift, and then glides back to its starting point.